So far, you guys have understood what is a quadratic equation, correct? Last year, you guys have learnt about it. Now, what if you have some root where the discriminant is less than 0? You know, an equation with discriminant less than 0. Now, last year you have learned that those are non-real roots, or sometimes you must have heard about the word complex roots or imaginary roots. Now, in this chapter, you guys are going to understand about complex numbers. Okay, so this chapter is called complex numbers and quadratic equations. Okay, this is the chapter name. Now, what exactly do we mean by complex numbers? You have to understand that. Now, in this chapter, you have a lot of things based on complex numbers. Okay, you are going to talk about what is a complex number. We start from that, the basics part. Then we talk about the algebra of complex numbers, where you have addition, subtraction, those 4 basic operations. Then we take the complex number, we calculate the conjugate of it, we have a lot of different ways of mathematical operations on these complex numbers. This is one more. And we also have properties such as representing the complex numbers in terms of the exponent, that is also there. Alright, and representing this on the plane, xy plane, but it's not exactly an xy plane, but you will figure out what it is. Then including the concept of this complex numbers in quadratic equation, very simple ones. Now let's try to understand what is a complex number. Alright, now whenever we talk about a complex number, first suppose say you have an equation, say x square plus 1 is equal to 0. Then x square is equal to minus 1. There is no real number which is going to give you x square as minus 1, because you know that square of any real number is always positive, irrespective of whether it's positive or negative in real number, correct? Like if you take x as minus 1 whole square becomes plus 1. So, to understand how complex numbers work, we start with x square plus 1 is equal to 0, a very simple example. So, x is equal to root of minus 1. Now, the root of minus 1, we call this value as x is equal to I. So, I is a complex number what we use. In the sense, I value is nothing but square root of minus 1. This is a very, very important part, where we say that any complex root or any complex number can be represented in terms of I. Like, for example, suppose say you have suppose say you have square root of minus 4. Assume this you can split as root of minus 1 into root of 4. Root of minus 1 is I, root of 4 is 2. So, we will get this as 2i. We get it as 2i. Again, plus or minus, we don't bother too much about the plus or minus 2 part as of now. So, what you need to understand is, suppose if you have square root of a negative number, then how we represent it is very important. And root of minus 4 is 2i. Likewise, suppose if you have square root of minus 9, this becomes 3i. Like this, we use this complex number to represent all sorts of numbers which is in the number line or which might not be in the number line, because number line contains every real number. Now we are looking at numbers which are not even present on the real number, correct? Those are complex numbers. So, whatever you have, everything can be represented in terms of complex and real numbers. Alright. Now, in the next video, you will understand different properties of this complex numbers, addition, subtraction, all those things. Alright. So, in the next video, you will see the algebraic properties of complex numbers.